Have you ever been to a huge concert and just wondered how on earth they get the sound to be so crystal clear for everybody? Well, it's not magic, it's just really, really smart audio engineering. Today, we are going to pull back the curtain on the science of time-aligning delay speakers and see how the pros turn what could be a muddy mess into absolutely perfect sound.
So let's start with something I think we've all experienced. You're at a massive festival, you're way, way in the back, and the sound just feels kind of off, right? It's like this distant, muddy echo, especially when you know the people up front are having an amazing time. This is a classic audio problem, and today we're going to see exactly how engineers fix it. I mean, the difference is literally night and day. Up at the front, the sound is clear, it's punchy, you can feel it, but in the back, it can turn into this smeared, confusing mess of echoes. And this right here shows us that the core problem isn't just about volume, it's all about timing. Okay, so let's get into the science of it all. To actually fix this problem, we first have to understand why timing is everything, and why some sound waves actually need a little bit of a head start. It all comes down to this one number, 343 meters per second. That's the speed of sound. Now, that is incredibly fast, don't get me wrong, but it is not instant. And over the really long distances of a huge concert venue, that little bit of travel time becomes a major, major factor.
And that brings us to the solution, time alignment. So what is it? Well, it's the process of deliberately delaying the sound from the closer speakers, the ones in the middle of the crowd, so that it arrives at your ears at the exact same time as the sound from the main speakers on stage. Think of it like this. You have two runners starting at different points on a track, but you time them perfectly so they both cross the finish line together. That's what we're doing with sound.
And this number, this, is the key to everything. Roughly 2.9 milliseconds. That's how long it takes sound to travel just one single meter. For any sound engineer out there, this is the crucial conversion factor. This is the little piece of magic that makes all the calculations work.
Okay, so we've got the why. Now let's dive into the how. It all starts with a really basic calculation that lets us turn physical distance into incredibly precise timing. And here it is. This is the magic formula. The delay you need, in milliseconds, is simply the distance in meters multiplied by 2.9. I mean, it is beautiful in its simplicity, right? And this one little equation is the foundation for getting that perfectly clear sound across a gigantic field. So how do engineers actually use this in the real world? Well, it's a surprisingly straightforward three-step process. First, you just measure the distance from the main stage speakers to your delay speakers. Second, you plug that distance right into our formula to figure out the delay. And third, you program that exact time into the system's brain, the digital signal processor, or DSP for short. Let's just walk through a quick example to make it real. Imagine your delay speakers are set up 30 meters back from the stage. Okay, so the front of house speakers, the big ones at the stage, they're always our 0 point, a reference. So we take 30 meters, we multiply by 2.9, and we get 87 milliseconds. That's it. That's the delay we program for those speakers. Simple as that. But here's the thing. That basic math, that'll get you about 90% of the way there. To get that truly pro-level sound, engineers have a few more secrets up their sleeves. So let's look at what really separates the pros from the amateurs. For absolute ultimate precision, the pros don't just rely on a tape measure. No way. They use these specialized measurement tools like SMART. What they do is they place a microphone right in the delay zone, and they literally measure the arrival time from both sets of speakers, and then they tweak the delay until those sound waves align perfectly. The goal here is something called phase coherence, which is just a fancy way of saying maximum clarity and punch. But perfect timing isn't even the whole story. There's also this really cool psychological trick called the Haas effect. See, our brains figure out where a sound is coming from based on what arrives first, even if it's just by a few milliseconds. So the goal is to trick everyone's brain into thinking the sound is coming from the performers on stage, not from that big speaker tower right next to them. And here is how they do it. This is the pro move. They add an extra 5 to 10 milliseconds of delay on top of what they already calculated. It's this tiny little adjustment, but it ensures that the sound from the main stage always hits your ear a fraction of a second before the sound from the delay speaker. It's a small tweak that makes a massive perceptual difference. All right, let's wrap all this up with some essential rules of the road. These are the key tips that every single sound engineer lives by. First up, a cheat sheet.
You can see really clearly here how the delay time scales up perfectly with distance. Honestly, a lot of engineers have these kinds of numbers just memorized so they can make really quick, accurate estimates when they're out in the field.
And finally, we have the golden rule of placement. And this is absolutely critical. You can't just stick a delay speaker anywhere you want. You have to place it where the sound from the main stage has naturally dropped off by about 6 to 10 decibels. If you get this part wrong, you don't solve the problem. You actually just create new weird audio zones and probably make things even worse. So there you have it, the science, the math, and the pro tricks behind getting that perfect concert sound. You now know exactly how engineers take a potential muddy mess and turn it into total sonic clarity. The only question left is, now that you know the science, do you think you could design the sound for an entire stadium?